All right, check this out, man. So right here, we could go to a distant sun as well. Right now, I've got it set to just 3,128. If we go to a distant sun, though, on this, just know it caps off at 2 million. Restrictions in the hardware will not let me go up to 93 million, unfortunately. But you get the idea. So that angle at the top, angle G, is a real tiny angle. And you can see it kind of comes like almost like a rectangular type shape at the bottom here. It almost looks like it's going to be a four-sided shape because this is so gradual right here. Now, if I wanted to compare this to the flat Earth model, let's go back to a local sun, so that's 3,000-ish miles. You can also change the height going like this as well. But there's two options here. I like this option here because if you're standing right here at point E and you measure 31.47, whether that's a curved or a flat Earth, you're still going to get 31.47 when you measure that. This and this are the same color because they're the same distance. That's your ground distance there. And there's also a comparison here where if you want to make the heights match up and the bases match up. However, since this angle D here is 114 and this angle D is only 90, that means that they're not going to have the same angle E doing it this way. 42 degrees for that angle E and 31 degrees for that angle E. Angle G matches up the same on both. And as long as you choose this one right here, angle E also matches up. I wanted to show you something here with the distant sun. This one here, if we measure 65 degrees to the sun right here, then what that's telling us is if the Earth was flat, the sun would be 7,376 miles in the air compared to 2 million miles in the air over here. We can see the math just is not working on the globe. It's a little wonky here. Even the shape's a little wonky. Let me move some of this stuff around here so we can use it later. So I don't know if you understand how this is all working here, but so you can change the size of the ground. Change the size of the ground on one, it changes the size of the ground on the other. It's easier to see if you go to local sun. Again, this is the prettier model, but it's unrealistic as a comparison because on the curved Earth, if that were a thing, you would measure 39 at this point here, 39 degrees. So to make it match up, we need to go to that model right there. So this just kind of gives you a little bit of a comparison here. And you can see the difference here, This one here should be at 2,000 miles. And even though this is the same angle on a curved Earth, would be at 3,000 miles. One cool thing too is right here, you can see when the ray of the sun goes underneath the ground, it doesn't work. So I guess another thing I was hoping you could do for me was seeing if this angle of 27 degrees, I guess my question is that the maximum that you can see? That just does not seem right to me right there. Other than that, this is round 2, and give me some tweak advice and I can move on to round 3 here. Make this thing work a little bit better. And that looks like that covers everything.